Some space probes die quietly. Others are murdered on purpose, steered straight into a planet to protect an ocean hidden under one of its moons. Another still drifts, powerless, guarding a dwarf planet like a ghost. But the strangest survivor of all carries a message pressed onto copper in under 6 weeks, riding the farthest human-made object to leave home. The Empty Minefield. For years, astronomers worried that the belt of rubble between Mars and Jupiter was dense enough to shred any spacecraft that tried to cross it. On March 2, 1972, NASA launched Pioneer 10 straight toward it anyway, the first probe built to punch through the belt and reach Jupiter on the far side. 4 small nuclear generators mounted on long booms supplied barely enough electricity to run a couple of household light bulbs, so every watt had to count. Picture yourself riding along on that instrument deck that July, crossing a donut of rock and dust for months, waiting for impacts mission planners had feared would end the flight early. They almost never came. Pioneer 10 crossed the belt intact, reached Jupiter in December 1973, and sent home the first close-up pictures of the giant planet's clouds. It also carried a small gold plaque, etched with a man, a woman, and a map showing the way home, launched during the coldest years of the Cold War as a quiet bet on peace. 3 decades later, the power that had kept its radio alive finally dropped too low for anyone on Earth to hear it. NASA received Pioneer 10's last weak signal on January 23, 2003. The belt everyone feared had proved to be mostly empty space, and Pioneer 10 kept sailing outward long after Jupiter had disappeared behind it. The inside-out furnace. At the German Space Operations Center near Munich in April 1976, engineers watched Helios 2 make the closest pass by the Sun any spacecraft had yet attempted. The joint German-American probe spun once every second and relied on mirrored surfaces and adjustable louvers, slatted vents that opened and closed like blinking eyes, to manage the heat pouring in. At its closest approach, about 27 million miles from the Sun, its sunlit skin reached roughly 700 degrees Fahrenheit, close to the peak setting on a self-cleaning kitchen oven. Stand with the instruments in the central compartment, though, and conditions stayed almost mild. Engineers had designed that inner chamber to hold between a chilly 14 and a comfortable 68 degrees Fahrenheit, not far from an ordinary room. That spring, Helios 2 set records for both speed and closeness to the Sun that held for over 4 decades. No famous scientist fronted this mission the way later probes would get one. It was the work of a small international team solving a thermal puzzle nobody had solved before. Helios 2 far outlasted its planned 18-month lifespan. Its transmitter finally failed on March 3, 1980, and Mission Control let it go quiet, still coasting in the orbit it had once used to outrace every machine built by humans before it. The machine that killed itself. If a spacecraft finds proof that a moon might hide an ocean, one way to protect that ocean is to destroy the spacecraft. That was the logic NASA settled on for Galileo by September 2003. The probe had launched aboard the shuttle Atlantis in October 1989, and the Challenger disaster had already forced Galileo into years of storage and a longer route to Jupiter before it left the ground. In April 1991, its main antenna, nearly the width of a 2-car garage when fully open, jammed partway through deployment and never unfolded. Investigators traced the failure to friction in the mechanism holding the ribs closed, after a coating meant to keep dry lubricant in place had worn away. Right along anyway. And Galileo still spent 8 years circling Jupiter on a backup antenna, soaking up far more radiation than its electronics were built to survive. What it found upended the old textbook picture of the moon Europa as a dead, cratered rock, strong evidence of a liquid, salty ocean sealed under the ice. That discovery is why the mission had to end this way. On September 21, 2003, controllers steered Galileo into Jupiter's atmosphere at more than 100,000 miles an hour, destroying it on purpose so a drifting, lifeless probe could never fall onto Europa and contaminate the ocean it had just found. The comet that fought back. The plan looked simple. A lander would drop gently onto a comet, fire 2 harpoons to anchor itself, and drill into the surface for a sample. Almost none of it went that way. Rosetta had launched in March 2004 and spent a decade looping through the solar system before catching up to Comet 67P in August 2014. Becoming the first spacecraft ever to settle into orbit around one. As the comet came into view, scientists realized it wasn't a single rock at all. Its 2 connected lobes gave it the unmistakable silhouette of a rubber duck. On November 12, 2014, the washing machine-sized lander Philae touched down first. Cross those 2 hours with it and you'd feel the harpoons fail to fire, the lander bounce off ground far harder than engineers had planned for, and drift in near weightlessness before finally settling sideways in a shadowed crack, its solar panels starved of light. For decades, comets had been pictured mainly as loose, dirty snowballs that simply melted as they neared the sun. Philae's instruments found a surface tougher and more solid than that picture allowed, hard enough to throw a lander back into space instead of holding it. 2 years later, in September 2016, controllers guided Rosetta itself down onto that same stubborn comet, ending the mission exactly where it had begun. The Astronomer's Last Flight. Clyde Tombaugh spent months in 1930 squinting through a machine called a blink comparator, flipping between photographic plates of the night sky, before he spotted a faint dot that shouldn't have been there. He was 24 years old, and the dot was Pluto. He died in 1997, decades before any spacecraft could fly out to see what he'd found up close. New Horizons launched in January 2006, carrying inside its upper deck a small aluminum capsule holding some of his ashes, engraved with words calling him the discoverer of Pluto and the solar system's third zone. On July 14, 2015, the probe passed within about 7,800 miles of Pluto's surface, roughly the distance between New York and Mumbai. Spend those hours with the mission team at their command center in Maryland, and you'd sit through a long, nerve-wracking silence. The spacecraft too busy photographing Pluto to phone home, any signal it did send needing over 4 hours to cross back to Earth. That evening, word finally arrived that New Horizons had survived. The images that followed erased decades of illustrations showing Pluto as a frozen, inert rock, revealing young, uncratered ice plains and mountains built from frozen water, evidence of surprisingly recent geological activity. Tombaugh had found a faint point of light in 1930. 85 years later, his ashes flew past a world still very much alive. The 6-week letter to eternity. NASA gave Carl Sagan's team less than 6 weeks to decide what belonged on a message meant for whoever, someday, might find it. Voyager 2 launched on August 20, 1977, and Voyager 1 followed 16 days later, each craft carrying a 12-inch gold-plated copper record, the same size and shape as any vinyl LP that might have been spinning on a living room turntable that same summer. The record held greetings in 55 languages, whale song, thunderstorms, and music ranging from Bach to Chuck Berry's Johnny B. Good, along with 115 images chosen by Sagan's committee. Sit in on those arguments and you'd hear the real disagreement fast. How do a handful of people decide what an entire planet wants to say to eternity? 13 years after launch, in February 1990, Sagan talked skeptical engineers into turning Voyager 1's camera back toward home for one last photograph. From nearly 4 billion miles away, Earth showed up as a single speck of light smaller than a pixel, the picture Sagan later named the pale blue dot. Both Voyagers have since crossed the heliopause into interstellar space. As of 2026, Voyager 1 is still checking in with Earth, almost 49 years after launch, running on just 2 of its original instruments and farther from home than anything human hands have ever built, its golden record still bolted to its side. The ghost ship that stayed. Vesta and Ceres, 2 leftover building blocks of a planet that never finished forming, still tumble through the main asteroid belt, orbiting the Sun in the crowded gap beyond Mars. Dawn launched in September 2007 to visit both, reaching Vesta in 2011, leaving it in 2012, and settling into a stable orbit at Ceres in 2015, the only mission ever to circle 2 different worlds beyond Earth. The trip ran on an ion engine, a thruster so gentle its maximum push amounted to about the weight of a single sheet of paper resting on your palm. Hover over Ceres with Dawn in its final months and you'd be skimming barely 22 miles above the surface, closer than most airliners fly above the ground. Inside a crater there called Occator, Dawn found blindingly bright deposits, salts left behind by liquid that had once welled up from underground. By late 2018, the fuel that kept its antenna and solar panels aimed correctly ran out, and the spacecraft went silent for good. Nobody sent it crashing into the world it had explored. Planetary protection rules required its dead orbit to stay clear of Ceres for at least 20 years, with engineers giving it better than a 99% chance of holding for 50. Dawn still circles there today, a powerless orbiter, keeping the door open for whichever mission comes next. The armored tank at Jupiter. Jupiter's magnetic field is roughly 20,000 times as strong as Earth's, powerful enough to whip charged particles into a radiation storm that can fry ordinary spacecraft electronics within hours. Juno launched in 2011 and reached Jupiter in the summer of 2016, built specifically to survive that storm long enough to do its job. Engineers packed its most sensitive computer and electronics inside a titanium vault with walls about a third of an inch thick, the whole enclosure weighing close to 500 pounds, roughly as heavy as an upright piano. Climb inside that vault with the electronics, and the reason becomes obvious. The titanium cuts their radiation exposure to a small fraction, about 1/800th of what waits just outside. Even shielded, Juno is expected to absorb a radiation dose equal to tens of millions of dental X-rays over the full run of its mission. What the spacecraft found once it settled into orbit upended a decades-old assumption. Scientists had long pictured Jupiter hiding a small, dense, solid core at its center, something like an oversized rocky planet buried under all that gas. Juno's gravity measurements showed something stranger. A core that isn't sharply defined at all, but blurred and diluted, blending gradually into the metallic hydrogen around it. Some planetary scientists propose that fuzziness is a scar left by a head-on collision with another massive world early in Jupiter's history. The man who touched the sun. In 1958, a young physicist named Eugene Parker proposed that the sun constantly sheds a stream of charged particles outward, what he called the solar wind. Two reviewers at the Astrophysical Journal rejected the paper outright. The journal's editor, Subramanian Chandrasekhar, could find no actual error in the math and published it anyway. 60 years later, in August 2018, NASA launched a spacecraft named after Parker while he stood watching, the first time the agency had ever named a mission after someone still alive to see it fly. Parker's solar probe carries a heat shield about 8 feet across, roughly the size of a small backyard trampoline, built to face temperatures near 2,500 degrees Fahrenheit on its sunward side. Stand a few inches behind that shield, and the instruments there stay close to room temperature the entire time. On December 24, 2024, the probe swept within about 3.8 million miles of the sun's surface at roughly 430,000 miles per hour, faster than any spacecraft ever flown, breaking the records Helios 2 had set in 1976. Parker studies the sun's outer atmosphere, where temperatures somehow climb to millions of degrees, even though the visible surface far below is cooler. The theory two reviewers once tried to bury became the reason a spacecraft now flies through the very mystery Parker spent his career defending. The funeral in mission control. On September 15, 2017, engineers at NASA's Jet Propulsion Laboratory watched Cassini close out 13 years in orbit around Saturn. The school bus-sized spacecraft had left Earth in October 1997, reached Saturn in 2004, and released the Huygens lander, which touched down on the moon Titan in January 2005, the first landing ever made in the outer solar system. Cassini later flew straight through geysers erupting from the moon Enceladus, confirming a hidden ocean under its ice. Anywhere in that control room during the final minutes, you would have seen engineers who had worked on this spacecraft for decades, watching one thin telemetry line on a screen. Cassini was nearly out of fuel, and a drifting, uncontrolled probe could someday have crashed into Enceladus or Titan, so controllers steered it into Saturn's atmosphere instead, thrusters firing at full strength the whole way down, not to save the spacecraft, but only to keep its antenna pointed at Earth for a few more seconds of data. Because Saturn sits so far away, the plunge itself happened about 83 minutes before Mission Control registered it happening. The spacecraft's final signal will be like an echo, project manager Earl Mays said beforehand, and at 7:55 that morning Eastern Time, the echo finally arrived and went flat. A probe that had spent 20 years protecting its own instruments ended by protecting the worlds it had found. Let us know in the comments which of these 10 machines you'd want to ride along with.